Okay, good day. So in this video, we will be discussing the first installment for um, the second, the first installment for the third series of videos covering AC43. So the third series, we will be covering simple ordinary annuity and simple annuity due. So before we go forward with our discussion, let us first define different annuities based on term, payment, and the length of payment and interest compounding period. So now, for annuities with classified by term, we have annuity certain. So when we say annuity certain, it means that the start and the end of your um, term or your note or your annuity payments or your payments um, is known. When we say perpetuity, the start is known, but your payments will not end. So by perpetuity, it means the payments are perpetual, meaning forever. Contingent annuity is that the start of your payments is known, but the end is not yet certain. So your payments will end once a certain condition is met. Okay. For annuities classified by dates of payment, so we have ordinary annuity. By ordinary annuity, it means that your payments occur at the end of each period or at the end of each compounding period. So when the compounding period is monthly, so at the end of each month, when the payment occurs at the beginning of each period, so if the compounding period is monthly, your payment occurs at the start of each month. For deferred annuity naman, guys, we will be discussing this after midterms or along with perpetuity. When we say deferred annuity, um, the start the start of your payment does not occur on the date jud of your term. Parang there is still a period of rest before the payments will start. And that period of rest is what you call the period of deferment. So by deferred, meaning naa pa siya pahulay gamay, aya ang payments dayon. Okay? So when we say annuities classified by length of payment and interest compounding period, simple annuity, guys, means the payment interval is equal. Okay? So the payment interval is equal and the payment interval coincides with your interest compounding period. So when we say payment interval, it means katong kung payment interval nimo is monthly, so monthly siya, or quarterly, kada quarter. So that's your interval. So when we say additive man good, guys, the interval of payment is equal and the size of the payment is also equal. So 100 per month, so that's your payment interval and your size of payment. Thus, the size of the payment is 100 pesos and the payment interval is your monthly or pwede po siya quarterly. Okay? When we say naman complex annuity or general annuity, um, one example would be the payment occurs monthly, but interest is compounded quarterly or semi-annually. Other cases would be payment occurs every 6 months, but your interest is compounded quarterly. So, na instances guys kung mas taas si payment interval kaysa kang compounding period, butong 6 months ang payment interval, kada 6 months lang ka magbayad, and then ang interest is computed, um, uh, the interest is computed quarterly. Okay? So, muna siya ang case nga the payment interval is longer than the interest compounding period. Payment interval is every 6 months, but interest is compounded quarterly. The other case would be the payment interval is shorter than the interest compounding. So, the payment interval occurs monthly, but then your interest is compounded annually. Okay, so that's the case there. For complex annuity or general annuity, we will be discussing that later on sa pinaka-last na yun before mag-final exam. So for now, in this series of video, the third series of video, we will be discussing simple annuity. So meaning equal ang payment interval and interest compounding period. So simple annuity nga ordinary annuity. So simple ordinary annuity, so meaning the payment interval is equal and the compounding interest period is equal, and payments occur at the end of each month or each period. While the second installment for this series would be simple annuity due. So same po no nga, the interest compounding period and the payment interval are the same or equal, and then the payment will start at the beginning of each period. Okay, so since we're done now with that, by the way no, so payment interval again katong distance, katong kung kapila ka the length of time nga kada mag-occur ang imong payment. So, 'di ba before we went to this chapter, we discussed about simple interest. Oh my god. We discussed about simple and interest and compound amount or compound interest. Compound interest. Okay. So here, for this two, we were only talking of one-time payment. Okay. So meaning, kaisa lang ka magbayad or marag, unlike equivalent values, dahil naman itong payment. But in a sense, marag iyahang thought about the simple interest and compound interest is that the payment occurs only once. Or if twice, different sizes. Mag-anak bitaw. So, while when we talk about annuity, guys, it's talking about a series of payment. Series of equal payments paid at equal intervals. Muna siya nga to ang annuity. So, the size of the payment or the payment is not done only once. The payment is done in a series of payments. So, unlike sa simple interest or compound interest nga, ang ihatag sa mga problem is ang present value is kani siya pila ang future value. So, meaning, ang mag-anak lang or kaisa lang ka magbayad ng principal, tas ang mga anak na is anak sa principal ug anak sa interest. For compound interest, for simple interest naman, principal ug ang iyang anak na interest, mara lang to siya. For annuity, guys, we're talking here about magbayad kag initially, lungagan na po nimo siya og another payment, lungagan naman na po nimo siya og another payment. So, sa first nimo nga payment, pagka after one period, na nato siya interest nga gianak, magdugang pa jud kag another na po nga payment, and then pagka next period, katulad po sila nga grupo sa kwarta, ang mag-anak pagka next period, and then mag-add pa jud kag additional payment. So, that's annuity. So, now let's go to ordinary annuity, solving for future value. So, the future value formula for ordinary annuity is FVOA, or future value of ordinary annuity, is equal to payment. So, this is your periodic payment. So, katuig mo akong ingon nga kanang gabayad ka every monthly. So, that's your payment multiplied by 1 plus I raised to the power of n minus 1 over I. So, if I put this into a representation, so let me just para medyo magka-idea mo on how it looks like kung plaster siya, no? FV, let me just, okay. So, equation, where's the subscript here? Okay, this one. So, FV, or future value of ordinary annuity, is equal to payment multiplied by okay, and then fraction. So multiplied by 1 plus I have to do this, but this one. Okay. So 1 plus I raised to the power of n minus 1 over I. Okay. So just in case nga mawala na ba ni siya kung ako na nang i-upload. So let's just paste it as a photo or a picture. Paste special picture. Okay. So this is now your formula for future value of ordinary annuity. So for example, no, Jose wants to retire in 20 years, and for this purpose, he is depositing $200 at the end of each month in a sinking fund that pays 7.2% compounded monthly. If he will be doing this for 20 years, then how much money will be there for him when he retires? Okay, so we now know that our payment is at $200 per period, per month na siya, no? At the end of each month. Now, it's already said here na the payment occurs at the end of each month. So, diha pa lang daan, sure na yun ta nga, ordinary annuity siya. Because the payment occurs at the end of each payment interval. Okay? So, the payment interval is each month, so monthly, and the interest is compounded monthly as well. So, nag-coincide imong payment interval and the interest compounding period. Therefore, this is a simple ordinary annuity. So, our I here is, of course, 0.072 or 7.2% divided by 12 because we're doing here monthly. So, same siya nga I sa ato ang compound interest and simple interest, compound interest nato. For our N, this is the similar N sa ato ang compound interest, which is our M, the number of compounding periods per year. So, that's 12 multiplied by the term of the loan, which is 20. So, you'll have 240 nga number of compounding periods. Okay. So, if we replace it, no, if we okay. So, if we replace it here, so we know that our payment is 200 and our I here. So, to be safe, no, para gyud maapil ang tibuok nga decimal points, I usually do this. Okay. And for our N, we already know it's 240. Okay. So our I here is 0.072 over 12. Okay. So let me just okay. So here. So after that, so replace we solve this using our calculators, or in this case I can use the Excel. So that's 200 multiplied by 1 plus 0.072 over 12 raised to the power of 240 minus 1 all over 0.072 over 12. So that should give us this as our future value of ordinary annuity. Next, so we have the question here, guys, is for how do you solve for a problem when the payment is the one which is unknown? So the payment is the one which is unknown. So for the payment here, we can transform the formula by expressing it this way. So we can do it like this. Anli na lang. Wait lang. Okay. Let me just copy this one. Sorry. Oh, what's happening? Okay. So if the payment is unknown, so we simply have to transform this. So ang from this one, mahitabo dayon siya nga um, payment. Ato na lang ni ibali, no? Ato na ibali. Okay. So this is payment. Okay. So equals payment. A payment. This no, this is FPOA. Ah, okay. Equals equation scripts. Okay, this one. So FD ordinary annuity. Okay. So this is the parang transition nga formula, no? And then since payment is the one which is unknown, we can simply then transfer this expression here to the other side. So we'll have um, we'll have FVOA all over that one. Okay. So now remember na when a fraction is a denominator, we can transform the formula into a multiplication by reversing the fractional na denominator. So if we do that, what will happen would be this one. So we can add or payment here is equal to FVOA multiplied by multiplied by um, fraction our I all over this one. Okay. So you can express your formula like this or like this. So as you can see, we change the division here to multiplication by simply inverting our denominator in a fraction. So how do we apply that to our problem? So here, so this is our future value of ordinary annuity. We multiplied that by our I of 0.772 over 12, and then we divide all of it by 1 plus the I, 0.72 over 12, raised to the power of 240, all minus 1. Okay? So that should give you a 200 pesos na 200 pesos na payment, which is equal naman here sa ato ang payment sa stated sa isa sa first problem. So let me just copy this. Ah, that's good. Okay. Okay. So that is now our formula. Ah, okay. Now, the next question is, what if the unknown is the N and the T? Okay. So we don't know here. What is the, what do you call this one? The number of payments that you will make to um, for you to be able to accumulate your money to the future value of 106,000. So you pay 200,000 monthly. The interest is 0.72 per 7 to 0. The interest is 7.2% annually compounded annually. The the interest is 7.2% compounded monthly, and then your payment is 200 per month, and your future value is 106,752.47. So the question here, Dion, would be, how many payments will you have to make to accumulate money of 106,752.47. So here, the formula derivation is shown here. So this is FVOA is equal to payment times 1 plus I raised to the power n minus 1 over I. So we reverse the formula here, and then we can now, what we did on the second one is we transferred payment to the other side, so it's FVOA over payment, and we can also transfer I from the denominator to the numerator. So that's FVOA times I over payment is equal to 1 plus I raised to the power of n minus 1. And then after that, we can transfer minus 1 to the other side, so we can have plus 1. And then, since this is our unknown value is an exponent, we will now then use the logarithm function. So that's log of this entire expression, FVOA times I over payment, all plus 1, and then all over log of 1 plus I, or you can express it by using this. So log of FVOA times I over payment plus 1 to the base of 1 plus I. So you apply that to your input that to your calculators. So this is how it should look like. And if we input that to our calculators, no, so that's um log of um 106,752.4678 multiplied by 0.072 over 12 over 200, and then we have plus 1, and then divided by log of 1 plus 0.072 over 12. So log of 1 plus 0.072 over 12. Bakit may error? Oh, sorry. Ah, okay. Mm. So the answer there is 240. So that's 240 periods. And as you can see here, we have 240 periods. So here guys, no, this is 240 periods. So that's the end. But what if you will be asked how long will it take? So meaning you have to translate this and express this into a number of years. So what you can do here is you have to simply divide this by 12, and you'll have 20 years. Sir, what if, this is just a what if, guys, no, what if what you had, or what you got was 250 or 55.86. So what if this is what you got as your answer? So how long will it take? So first is you have to express this in years, di ba? So in years, so since we know that this is monthly, so this is a number of years, so that means we have to divide this by 12. So you have 21 years, 21 years na ni siya. So that means 21 years. And then you get the remainder. So the remainder would be, and then we multiply this remainder by, um, uh, what do you call this one? After the year, we have to express it naman dayon by months, right? So by month. So, since by month na siya, we multiplied, how many months are there in one year? So, we multiply this by 12. That means we have a whole number of 3. So, that's 21 years, 3 months. And how much do we have left? 0.86. How many days are there in a month? We assume 30. So, that's 30 times like that one. So 25.8, now we round up. So that means 26 days. So how long did it take to accumulate the money? It's 21 years, 3 months, and 26 days. So for example, the period was quarterly. So we divide this by how many quarters ba? How many quarters in Bulan lang quarterly ang gipangayuan, what you got was 255.86. So this quarterly means there are 4 quarters every year. So 4 quarters every year. So 4 quarters. That means you have 63 years. And then what 63 years. So our remainder would be okay, and then after that we transform this into monthly for the remainder. So because this means that this is a fraction of a year. So that's times 12. We have 11 months. 11 months. And another remainder. So this is 0.58 of a month, so we have to express it in days. So that should give you 18 days. So the entire period would be 63 years, 11 months, and 18 days. So that's how you solve for the term and the number of payments that is required to accumulate to that future value of ordinary annuity. So next is we have um, what if the unknown is your interest or your interest per period, your I. Not your inom yet ha, your I muna tayo, sa I muna tayo. Okay. Actually, what we can solve here is the inom eh. Okay, so let's go to our inom. Okay. So, for I, or for the interest rate, we cannot solve it by simply modifying the formula. The only way that we can solve this one is through interpolation. When we talk about interpolation, it means through trial and error. So here, we know that our FVOA is this one, as copied here, 106752.47. Our payment is 200. Our N is 240, and our M is monthly or 12. So here we simply assume values or like interest rates that we can apply to our formula here. So here we tried 10%, 9%, 8%, and 7%. So we will be solving for possible future values of this future values using these interest rates, given that the N is 240 months, the payment is 200, and the future value is 106. So this is our target. So we're trying to para bitang tinamban kung unsaon na to pagkuha, kung unsa dali nga interest rate ang mo shoot ani. ang mo-shoot sa 106. So our payment here is 200. So multiplied by 1 plus 0.10 over 12 raised to the power of 240 minus 1 over 0.10 over 12. So the present value for the present value for our what do you call this one? The present value for our um sabihin mo siya. Okay. The future value of an annuity, of an ordinary annuity with payment of $200 per month, and the interest is at 12%, and the total at 12% is at 10%, and the total number of payments is for 20 years or 240 periods at 10% na interest rate, no? So again, the future value of an ordinary annuity with a payment of 200, um the number of payment is 240 months or 20 years, and payment period or interest is compounded monthly at 10%. The future value is 151,873.77. So layo no, kaya to ang target is 106. So this is the year technique, guys, in trying to solve for kind of bitong what interest rate you can probably go for. So now, this is a future value, right? This is a future value problem. So since this is a future value problem, the higher the interest, the higher the future value. Okay? So in this case, diba, at 10%, what we got was 151,873. So your goal is 106,000. This one, 106,000 imong goal. So if your goal is 106,000 and what you got from 10% is 151,000, do you need to go higher or do you need to go lower? You have to go lower. So since higher interest rate means higher present value, future value, you have to, and then your target is lower. So since lower future value man imong target, you have to go lower sa imong interest rate. So now we go to 0.09. So sir, how did you kanang think, sir, nga you have to start at 10%? Usually I start at 10 or 12%. So that is my benchmark, kumbaga. Kasi usually problems mag-start dito. So I start usually at 10 or 12% para I have room for going up or going downwards. So since I need some lower present value, no, I need to go lower, so I went for 9%. So using the same formula but changing the interest rate to 9%, I got 133,000. Still taas pa gyud kapon kay siya sa kumpara sa akong target. So I went down more to 8%, and by using 8%, what I got was, so same formula, same values, except sa 8% na lang imong interest rate. What I got is 117,000 na value. So taas pa gyapon, so I need to go lower. So I used 7%. So for 7%, what I got is in just replacing the interest with 7%, it gave me a future value of 104,000. Now, 104 is lower because my target is 106. But if I go for 8%, 117 is way higher pod. So this means that my interest rate annual is between 8% and 7%. So, muna na yun siya nga kanang year 8% now. Looking at the present at the future values ng given amounts, no, looking at the future values, your 106 is in between 117 and 104. So this is where we do that on our high-low method. So for our high-low method, we choose a high and we choose a low. So in this case, high of course is 117,000 and then low is 104. So there are two different approaches for this, no? So it's high minus x over high minus low. So in formula, it is shown like this. So para siyang ganito, fraction. High minus x over high minus low. Another variation for this one would be uh, x minus low and high minus low. Okay? Some people actually use the letter E. So, the letter E na high, x, low. So, what they do is this one, for example, so high minus x and high minus low, or x minus low, then high minus low. So, always lang remember lang yun guys, no? Nga, in the denominator, present yun dito si high minus low. What differs lang is the numerator, whatever approach that you would like. So, that's either high minus x or x minus low. But, I'll show you here that despite or that no matter what approach you will go for, you will still arrive at the same answer. So, how do we do that? So here guys, we know that our high, what is this? Okay. So our high minus low, so our high here is, of course, our x here is this one, right? This is our x. This is our unknown. So, our high minus x would be 117 minus the 106, and then the high minus low would be, why did it change? Okay. And then the second one would be high minus low. So 117 minus 104. And then you divide these two. So that's 11 divided by 13. So you'll get 0.81. Sir, what do I do with the 0.81? Now, what is your constant here? What is your constant in this method? What is your constant here? Your constant here is your high. So meaning high occurred twice. So meaning you have to your 81 is more it's either you have to add it or deduct it from your high. So your high here is 8% because this is your constant, right? This is the factor that occurred twice. So you start at 8%, and then your goal is between 7% and 8%. If you start from 8% and you want something lower than 8% because it's between 7 and 8, do you add the 0.81 to 8 or do you deduct it? If you add the 0.81, you will have something outside sa in-between ni 7 and 8. So that means you have to deduct your value. So that means for this one, it's 8 minus 0.81. So we will be trying 7.19%. On the second high-low approach, what we do is this. Same. So x minus low. Our x minus low would be our x of 106 less our low of 104. And then our high minus low, which is 117 over I minus 104. We divide the two. So we'll get 0.18 again. So what is your common here? What is your constant? Your constant here is your low because low occurred twice. You used your low value twice. So with that, your start is not 8 now. Your start is now at 7%. So if you start at 7 and you have something to add or deduct, to get a value in between 7 and 8, what do you do with that value that you have? Do you deduct it from 7? If you deduct it from 7, you will get a value outside of the in-between of 7 and 8. So with this, it means that if the constant is your low and which is at 7%, what you should do now is to add it to your base of low, which is 7. So 7 plus 0.18 is 7.18, and actually, they are the same values. So, sir, ganun naman ang lahi naman na siya, sir, because nakulangan na siya og interest rate. Sige. Interest rate. Nakulangan na siya og, okay. Diba? So same sila og values. Whether what which approach would you would use. Should always just think no na if in whatever uh kanang method you will use, always remember where do you start after you get your value. So asa imuhang kaduha gigamit. So in this case, we will try 7.19. So sir, is 7.19% your final answer? No, not yet. 7.19% is not yet your answer because interpolation is a process of trial and error, right? We already did trial and error a while ago. So after determining that maybe it's around 7.19%, we also have to try the 7.19 out to know if it's within or to know if it will give us the value that we are looking for. So in this case, we will try 7.19. So using the same values and the same formulas, so we replace the interest rate with 7.19. So, kana siya. So, same. And then we got 106,622. Dool na siya, pero murag napay discrepancy. So, let's try. Do we need to go higher or lower? Okay, so in this case, our x is higher. So, we need to go higher. So, in this case, now, since kanang ginagbay na dahil ato ang increments by kuan na siya, by 0.1% na dayon ang ato ang 0.01% na dayon atong increments. So in this case, from 7.19, we will go to 720 because we want our x is higher. Our x or our target amount is actually higher than what we have what we computed using 7.18. So using 7.2, so 7.2, it will now give us the exact value we were looking for. Sir, is this really always the case na nang equal yun siya sa imuhang what do you call this one? Na mo equal yun siya sa imuhang targeted amount? No, not necessarily. So in interpolation, no, always go for the interest rate that will give you a little bit higher na future value than a little bit lesser. Kung dili gyud siya mo inside. So always go with a little bit higher. Okay, so we're done now with our ordinary annuity. Future value, simple ordinary annuity, solving for future value, so future value of ordinary annuity. Now we will be solving for present value of ordinary annuity na topic. So let's go to that. Okay, didn't miss anything. Okay, so for present value naman of ordinary annuity, let me just check. Okay, for present value naman of ordinary annuity, what we have here is this. So the present value formula is like this, no? If you want it in the kanang parang mas guwapa nga form, okay, let me just copy this. Did I miss anything out here? What happened here? Okay, just in case nga mawala na siya. Okay, daan ka. Then, because it moved. Okay. So this is in case guys, no, this one kay possible man good nga mawala na siya. Possible nga mawala na siya once i-upload na ako na siya. So back up just in case. Okay, so that's the formula. Now, for present value of ordinary annuity, our formula is this one. So it's like present. It's simply like future value of ordinary annuity. What changes here is your table factor. This is your table factor, guys. In compound amount, our table factor is 1 plus I raised to the power of n. In future value, in compound amount, future value is 1 plus I raised to the power of n. For present value, it's 1 plus I raised to the power of negative n. That's for compound amount. for future value of ordinary annuity, our table factor is this one. This is our table factor. And for present value of ordinary annuity, our table factor is this one. Okay, so what only changes here is the numerator na part. So naalan tayo diri 1 minus, okay, and then the n here will be a negative n. Okay, that's the only difference there. By changing the numerator sa formula sa FVOA, it now becomes PVOA. Okay? So for example, no, after a down payment of $15,000, a car costs $60,000. The balance will be paid off in 60 equal monthly payments with the interest of 16% per year on the unpaid balance. Find the amount of each payment. Okay. So here, guys, we have here, this is a problem wherein there is a down payment, no? So if you will be asked how much is the cash price, the cash price is simply the down payment. I'm sorry. Down payment plus the PV of remaining payments. Okay, so this is the PV of the remaining payments. So in this case, given na si PV, no? We were asked directly of what is the size of the payment. So, kadit lang sir, gano'n, nag-payment ka diretso. Okay, kaya lang siya. This is to allow us, no, to have one problem and then we can discuss everything na dayon. So, in this case, let's solve na lang muna for the payment first. So, for the payment, guys, no, namadidiri? Kung saan pag-solve sa payment? Okay, wala. Okay. So, for the payment, we simply have to, sabi this, ay wala pa ako pala yung i-paste as photo. Okay. Yan naman ka. Okay. Okay, let's transfer you here na lang muna. Okay, let's go muna with the present value calculations first. Okay, so in this case, so after a down payment of 15,000, annuity payment is for 1,459.08 paid off in 60 equal monthly payments with the interest of 16.4% per year on the unpaid balance. Find the amount of unpaid balance. Okay, so here we ignore the 15,000 because what you're given is already it kanang what you are asked of is not the cash price. What is being asked of you is the remaining balance that you have to pay off. So since the remaining balance you have to pay off, it's asking now the present value. So how do I differentiate present value and future value problems in annuity? So in compound interest, ito simple because you can use a timeline man. You can see man if you went forward or you went backward. But you can also use the same concept for annuity. So for the first one, for our future value of ordinary annuity, the one we discussed a while ago, you paid now and then you will accumulate an amount later on. For present value naman, guys, you already have an utang here. What you're trying to do is you're paying it off ginagmay. Okay? So, pila na imuhang value sa imong utang karon. Kung magbayad ka o ginagmay para ma-impress siya. So, nana ang utang daan. Well, sa future value, ang imong part na kailangan, murag, dito pa nimo mahibaw-an. Dito pa. Pero for present value, kabalo na karon. Kung pila ang imuhang hinay-hinayag bayad. That's present value. Okay? So, in this case, we were asked of how much ba ang balance. So, using this formula no nga PVOA, so we can solve it by, so our payment is 1459.08, and then we simply change the other things. 1 minus why is it 16.4? 16%. Okay. Dapat consistent pa. 16%. So here, 16% over 12 kasi monthly nga. And then 0.16 over 12. So, as you can see here, guys, again, payment times 1 less 1 plus I raised to the power of negative n, because we have 60 equal monthly payments over I. So that should give you 559,999.86. Okay. So 59,999.86, or simply you can answer, let's stick to what we have. So 59,999.86. So your unpaid balance is this one. So unpaid balance, PV of unpaid balance. If you will be asked how much is the cash price, so it's simply 15,000 plus, oh my god, 15,000 plus our PV of unpaid balance. Okay? So that should give us 74,000 as our cash price, or almost 75,000. Now, if you will be given na ano, like what if, so for this one, if for this problem, for example, um if the question here was before a down payment of 15,000, a car costs 60,000. So meaning your unpaid balance would be 60,000 minus 15, because the total cash price is the 60,000 already. Kasi nga, di ba ang statement niya, before a down payment of 15,000, the car costs 60,000. So how much ang remaining unpaid balance nimo? So that's 60 minus 15. But since the statement is after the down payment of 15,000, a car costs 60,000. So in that case, it means nga the total cash price is 60 plus 15. So 75. And the unpaid is, as stated here, 60,000. So what if the payment is ano? So for the, if the payment is ano, no? Um, okay, so let's flip muna this. Let us flip muna our formula para mabalhin sa pikas na side. So this is script PVOA, present value of ordinary annuity. Okay? And then since payment is unknown, we can simply just, so this will be payments. This payment is equal to PVOA. Let me just copy you. PVOA, ay dapat kaya ano siya, no? Fraction. Just delete this. Okay. So that your formula now would be payment is equal to PVOA over 1 minus 1 plus I raised to the power of negative n over I, or simply, or you can also write it this way. Sorry for that. Mm-hmm. Ah, okay. So PVOA, so multiplied by I times. Okay. So again, same with our FDOA, no? We can change the operation from division to multiplication by flipping our denominator nga naka-fraction. So that's times I over 1 minus 1 plus I raised to the power of n. So let me just copy this to... Okay. So this is just to ensure that the formulas are intact even though I will upload it later on. Okay, so with this formula, no, with this formula, we can now solve for our payment. So that's 60,000. That's our present value of ordinary annuity, our unpaid balance, multiplied by I, so 0.16 over 12, multiplied by 1 less 1 plus 0.16 over 12, raised to the power of negative 60. So that should give us payment of 1459.08. So what if now the unknown is your N? Yeah, your N, your number of payments. So from this formula, we have this one. So from this formula, no, we will be solving for N here, our N here. So what happens now is that we can eliminate or we can transfer now I. So PVOA times I over payment. So we are left now with 1 less 1 plus I minus 1. Okay. And then after flipping it, we have to flip it again because our um, exponent is at a negative. So to make it a positive one, we have to, what do you call this one? To parang flip it from a negative to a 1 over 1 plus I with a positive n. So what went here, guys, no, is we simply transferred PDOA times I over payment to the other side. So name na siyang from positive to negative. And then we transferred the negative 1 plus I to the other side. So name mo siyang 1 plus I raised to the power of negative n. And then we in order to change the parang sign of the exponent, we have to translate it into a fractional nga expression nga with exponent. So pag ang negative n, pag imo na siyang imuong fractional, mahimo siyang positive pag mabali siya. So from numerator to denominator, nahimo siyang 1 plus I raised to the power of n. So in solving for n, so babalhin ni siya dito sa pikas nga side, so 1 plus I raised to the power of n from division to multiplication. And then this entire expression here will be transferred on the other side. So, dapat ko minus pa din ka plus. Okay. So, this entire expression will be transferred to the other side. So, we will now have 1 plus I raised to the power of n is equal to 1 over 1 less PVOA times I over payment. So, mga itong expression. And then, since we're kanang okay na si n, positive na siyang exponent, then we can solve using logarithm. Okay? So, with that, if the PVOA is 60,000, our payment is 14. So, let's just let's use the rounded off muna, be. And then, our I here is 0.16 over 12. N is 60. So, monthly, ang M is 12. T is 5. Ano? Wala pa ni. N is unknown pa. N is unknown pa. Okay. M is 12. Okay. So, how much is our N now? So, using our logarithm sa ito ang calculator, let's solve now. Our base is 1 plus I or 0.16 over 12. And our entire expression is a fraction of 1 over 1 minus another fraction. Yeah. Our PVOA is 60,000. We multiply that by our I of 0.16 over 12. And um, we divide by our payment of 1459.08. Okay, so this should give us 60 periods. Okay, so meaning you have to have 60 equal payments. So 60 monthly. So 60 monthly man, if you express that into the number of years, it will take you 60 divided by 12, 5 years. Okay, so that's how you solve for your uh, T. So for example, no, not you were able to get not 60 but 66.72. 66.72. How do we express this in years? So first is we express this muna um uh into the number of years, so divided by 12 to give us 5 years. 5 years. And our extra is sorry. Minus 5. Okay? So this is a fraction of a year. So a fraction of a year, the next would be translated into months. So times 12. So we have 6 months. And then we have remaining of 0.72, which is a fraction of months. So when we multiply this by 30 days in a month, that should give you 22 days. So that's the term um, of your annuity payments if your answer is like ingani 66.72 or dili siya buo. Okay? So next is how to solve for the interest rate using interpolation. Again, for interpolation, guys, all that we can use is a high-low method, trial and error, because we cannot just simply manipulate the formula. Okay. So, where are we? So our formula again is this one. Let me just copy this para mas guwapo siya. Yeah, this one. This is our formula. And then, so our PVOA is 60,000. Our payment is, let's just go with the rounded off na lang. Okay? And our N here is our N here is 60. So our unknown here is now our I. Okay, since our unknown is our I, uh-huh, uh-huh, uh-huh. Okay, now we go to our high-low method. Silabot. Right? Ay, apilo siya. Okay. So, ayun. What is this? Okay. So, included. Ay, lagi wala na siya. Okay. So, in this case, let's try solving it. Using 10%, no? So, that's 459.08 and then 1 less 1 plus I 10% over 12 raised to the power of negative 60 all over 0.10 over 12. So it will give us a present value of 68,672. Okay. Okay. So now guys, here as you can see, sorry. As you can see, 68,000, like very, very very layo pa no from our target of um what do you call this one, 60,000. So for 'di ba guys kanina, for future value, the higher the interest rate, the higher the future value. In a present value naman guys, the higher the interest rate, the lower the present value. So in this case, do we need to go lower sa atong present value from 68 to 60? So meaning we have to go lower. So since we need to go lower, we have to increase our interest rate. Again, for annuity payments, the higher the interest rate, the higher the present value, but the lower the present value. Okay? Again, for interest for an ordinary annuity, the higher the interest rate, the higher the future value, the higher the interest rate, the lower the present value. So since we need to go lower, we need to increase our interest rate. So our interest rate from 10%, let's go for 12%. So for 12%, sir, why did you no skip to interest rates? Of course you can. Kaya in this case, layo pa kita from 68 to 60. So we can just simply skip kanang what do you call this one? Interest rates in our trial and error para mas gamay ang atong effort. So ayun. So 1459 0.8 na percent divided by 12 is negative 60 0.12. That should give us a present value of 65. Still layo pa kaayo. Okay, another 2%. So 14. So let's try 14%. Okay, 0.14. It should give us 62. So 62 medyo dool-dool na ta. So balik tag isa-isa nga gap. So let's go for isa. What do you call this one? Say 0.08, and then so 0.15, that should give us 61. Dili pa gyud siya shoot. Let's go for 16%. So for 16%, like that, and then 0.16. Okay. Okay, 4.16. Okay. So this will give us 5999.86. Sir, can I stop na there because the difference is only 0.14. Yes, you may stop. 'Di ba I told you kanina na for future value, the higher na what do you call this one? The higher na future na amount that you can get if dili siya exactly better. Pero in cases like this, no nga, you can go higher, you can actually solve for a number between 61 and 59,999.86 to get the 60,000 para makmurag dito jud ka nga murag higher lang ka a little bit by chances sa 60,000. Pero in this case kasi very dual na siya, so you can stop there. So let's assume some other factors no na that will allow us to use our high-low method. So let's assume now that our PA butang talang na 65,000. Okay, so if our target is 65,000 and using this information, so 65,000 using this information, we now know we can stop actually here na dayon. We can stop here. By trying, okay. So, 10%, 68. Dili pa. 12%, 65,593. Duol na. So, what if we try 13%? So, let's try 13%. It should give us 64. So again ha guys, this is another example. So our 65% na target is between 65 and 64. So this is now your high-low. So high mo is the high value nga 65 and your low would be your low value nga 64. Sir, high-low, dili ka mo tan-aw dito sa iyahang interest sa gigamit. I prefer looking at the present value factors present value computations themselves than on the interest rate. Because as you can see guys, no, when it comes to future value, okay ra because murag proportional siya ba nga mas taas si interest rate, taas po si future value, mubo si interest rate, mubo si future value. So taas interest rate, taas future value, mubo interest rate, taas mubo future value. But for present value, it's the opposite. The higher the interest rate, the lower the present value. The lower the interest rate, the higher the present value. As you can see here, with 12%, the present value is 65,000, while at 13%, the present value is only now 64,000. So, nabalik siya. So, I would rather look at the amounts yun mismo. So, in this case, no, so this is our X. Same gyapon ito tutong high low sa ato ang PVOA. So, high is this one minus our low, our X, our X and then our high minus our low. I like that. Our high minus our low. So, that will give us a 0.40. So, 0.40. What do we do with the 0.40? Same thing that what we did on the present future value calculation and then si I ang unknown. So, kinsa man nga value nimo ang nabalik. Which value was your constant? Your constant was your high. So, we start at 12%. We're trying to get a percentage in between 12 and 13. So, in between 12 and 13, so the value that we got, we should add this to our 12 to get a value in between 12 and 13. So, 12 atong start, no? So, 12 plus this one. Okay. Ay, ano naman to? Ay, did I? 12 plus this one. Okay, 12.40%. We'll be using 12.40%. On the other hand, if we use the other route, katong x minus low, so this should give us x minus low and then high minus low. Okay, so same here. And then what should we do next? Determine what we used as our constant. We used as our constant low. So low, we start with low. So 13, to get a number in between 13 and 12, we have to deduct what we got from 13. So this is 13 minus. So this will still give you 12.40%. Do we stop there? Again, we don't. We don't stop there. Next is we have to try it out. We have to try 12.40% if it will give us the value that we're looking for. So 0.1240. So here, we will just copy this. So actually, wala na nilabo si 14, di ba? Kaya wala na siya nakakuan. Okay, we copy this. Sorry. Copy this. So at 12.40, we will use 12.40, 12.40. What will we have? We will have 65,000.80. Diba? Diretso shoot. So let's try. Let's try muna. Just for the sake of trying it out, no? Lapas siya 0.80 nga decimal. Let's try going lower. So if we want to go lower sa present value, we have to go higher sa atong interest rate. So let's try 0.1241. So 0.1241, how much will we get? Okay, 64,986.09, very far from the 65,000. So meaning our answer now would be at 12.40%. So that's for your that's the discussion for ordinary annuity. No, so again, you always remember when we say simple, because we're talking about simple ordinary annuity here. Simple annuity means the interest period and the payment interval are equal. Interest compounding period and the payment interval are equal. And ordinary annuity means the payment occurs at the end of each period. So kung monthly, at the end of each month, kung quarterly at the end of each quarter, and kung semi-annual at the end of every 6 months, kung annually at the end of every year. So if you have any questions regarding this video, please don't hesitate to contact me through our GCs. Also, please, what do you call this one? Please take note of any postings regarding the second installment for this series. So that's it for this topic. Thank you so much, guys, for listening. Have a great day.